Hello students, welcome to classroom. Today is a very important class because today we are going to learn a very important topic, which is image formation by spherical mirrors. The first mirror that we will discuss will be about concave mirror. So we will be learning the different cases. Okay, now most of the students, most of you have you have huge problem on this topic. Okay, like you don't know. Okay, most of you struggle here, but it is actually very easy. So before, okay, if you don't know how to do this, then I will request you to go and watch the previous video. Okay, there I have explained about the rules. So you have to be thorough with the rules first. Okay, once you are thorough with the rules, this becomes very easy. So I will sincerely request you to go and watch the video first, so that you get a sound knowledge. Okay, you get a solid concept of how to draw what is happening, because we will be using those rules to draw the ray diagrams only. Okay, so please, I request you to have a look at the previous video and then watch this video, so that you will be able to understand better. Okay, so now let's start away with our lesson now. So image formation by spherical mirrors. The first we will learn will be about concave mirror. So there will be 6 cases. Okay, so from cases 1 to case 6 we will discuss today. So let's start with case 1 first. So case 1. Okay, case 1. Okay, now I want you to grab your notebook and pencil and follow me. Okay, we'll do together. So all of you, okay, grab a notebook and a pencil. Okay, why a pencil? Because we are going to make a lot of mistake here, so we need to erase. So pencil will be better. Okay, case 1. Now follow the formats, follow the same format. Okay, it will be much easier if you follow the format that I'm using. Okay, so later on, if you follow the format which is given in the textbook will be easier for you to understand. So case 1, the first thing that we will do is, where is the object cap? Okay, we have to always address that. Where is the object cap? Remember, the object light, okay, light gets reflected from the object, so the object is always there. So the first thing while discussing any case is object position, then we'll discuss image position, then the size, and finally the nature. Okay, like that. So case 1, then you write object position. Object position. So in case 1 for concave mirror, where is the object cap? So remember, in case 1, whether it is concave mirror or convex mirror, in case 1, object is always kept at infinity. Okay, so you write here object cap, okay, at infinity. This is the object position. Okay, infinity, the symbol of infinity, you know, like this. Okay, so object is kept at infinity. All right, then afterwards we'll draw the image position also, and then nature and size also. So then right here image position, which we will fill up later, not now, but just let us make the provision for it. Okay, then size also we have to write, okay, which we'll fill up later, and finally nature. Okay, nature, what nature was it? Okay, so now let us do the ray diagram now. So I will draw it here, okay, so that I can at least write 2 more or 1 more case here. So case 1 we are discussing for concave mirror. So the mirror will look like this. Okay, back side will be drawn like this. Okay, pole is here, mark it with capital P, and then we draw the principal axis. Okay, we draw the principal axis. Okay, now then the first thing that we will do is we will mark the points on the principal axis. Remember, the center of curvature is a point on the principal axis. The focus is also a point on the principal axis. Even the pole, okay, even the pole can be set, okay, but actually the pole is on the aperture. Okay, but the principal axis touches the pole also, na? So we have already shown the pole. Now we will show the focus and the center of curvature. So remember how I do, isn't it? Make sure that, okay, you take precise measurement. So I want to keep the focus here. So this will be my focus, okay? Okay, this will be my focus. You can keep anywhere, but make sure that you have a scale, or you make a precise, accurate graphs of how much distance you are taking. So this is my focus, no? So this is this much. So this much, okay? This much. So the same thing, I'll take it back, and then I find it here. Then this becomes my center of curvature. This is how you get precise measurement of the points, okay? Especially focus and center of curvature. See, the distance should be same. This much gap, this much gap. All right. So in case 1, the object is kept in infinity. So here I will not be drawing the object. Okay, I'll not be drawing the object. Very soon you will know what object we are drawing. Okay, we are drawing a very simple object. So here I cannot show you the object because the object is kept at infinity. Infinity means very far. Okay, very far. Stars are at infinity, isn't it? We see the stars at night, but then even now we have never landed on the stars, so they are far away from us. Okay, so infinity. Okay, infinity. So object is at infinity. Then how will the light rays, okay, be coming from? How will the light rays be coming from an object which is kept in infinity? Light rays coming from the object placed at infinity, the light rays will be coming parallel with respect to the principal axis. So the light rays will come parallel. Okay, remember, light rays coming from an object kept in infinity is always parallel to the principal axis. Okay, so we will draw only 2 rays. Okay, class. So take one ray like this, ray number 1. Okay, and another ray you can draw it here down. You can draw like this. Okay, so ray number 1, and ray number 2. We will only take 2 rays. Okay, then now time to follow the rules. Now think the rules. How many rules did we study? 4 rules. Now which rule should I follow? Which rule should I apply here? Now I'll give you a hint. See, the incident ray is traveling parallel to the principal axis. Which rule does this fall under? It falls under rule number 1. Okay, correct. So rule number 1. So when the ray is traveling parallel to the principal axis, after reflection, how will the reflected ray go? The reflected ray will go, it will pass through focus, yes or no? So now the reflected ray will pass through focus. See, it will pass through focus. Okay, so this is the incident ray heading towards the mirror, touches the mirror here, reflection will take place, reflection is taken place, it has passed through focus. Image will be formed here. Remember, class, that image is formed at the point where the 2 reflected rays meet. Wherever they meet, wherever the reflected rays meet, image is always formed there. Okay, so from case 1 itself, we will get an image, but this image will be not visible to us because it is a point. It is a point image. It's just a dot. Okay, it's a very small image. Okay, point. So image position. Where is the image form? Image position means you have to tell where is the image form. So the image is formed at exactly focus. So we will write at focus. So image position at focus. Okay, class, you write at focus. Image position is at focus. Size. See, the size is very small. It's point size only. Okay, so point size. So we can't even we won't know what it is. So it is point size, isn't it? So image size is POINT, point sized, past tense. Okay, point sized. No? And nature, what will it be? Real or virtual? Anyone? Real or virtual? This will be a real image because the reflected rays, they actually do meet. Okay, class, so this is a real image. So nature is real. See, it's easy, isn't it? Now we go to the next case, case number 2. Okay, case 2, we will have to do the same thing. So object position, every time you will write object position. Okay, object position is, we have to write where the object is kept at. Then image position, image position, then size also we have to write, and finally nature. Okay, nature. So Okay, I can go for one more. So object position. Now in case 1, the object was kept at infinity. Okay, the object was kept very far away. Now, okay, now the object will be brought forward. Okay, in case 1, the object was at infinity, so it's like I'm out of your sight. Okay, I'm out of your sight. Okay, then now in case 2, the object will step up. Okay, it will step up. Got it? It will be visible now. So it will be like me standing here. Okay, and then gradually what will happen? The object will step up more, 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 like that. So that's basically how the object will move. Okay, so at case 1, the object was out of frame. Okay, if I am the object at case 1, me being out of the screen frame, that will be case 1, infinity. Okay, now the object is visible. So basically maybe this one. Okay, so I'm visible but not much visible. This is the object here. This is how the object in case 2 will look like. So the object position will be, so let's first draw the ray diagram. So so this is the back side, this is the pole, this is the principal axis. Okay, now this is the pole. Then immediately after you draw the principal axis, okay, you have to show the focus and the curvature. So let's do that. So let's say this is the focus. So you know what I do, is not, I will take the measurement of this one. So this much big, so this much, basically here. So the C is here. Okay, so this is my center of curvature, this is the focus, and this is pole. The focus is at the midpoint between C and P, isn't it? You already know that. So now where will the object be? The object will be standing behind center of curvature. So the object will be here. Okay, the object will be here behind center of curvature. Now what type of object will I be drawing? I'll be drawing an arrowhead only. Okay, so the object will be here. Okay, this is the object. So this is the object. Now let us draw the right. Okay, before that let's write object position behind C. Okay, let's write behind C, capital na, behind C. It's behind C. Okay, now why is it called behind C? Okay, because we consider the pole to be the front. Okay, so we are looking in this direction, that's why this object is behind C. Okay, because we are facing this. Okay, that's why it's called behind C. Okay, if we were going like this, then it will not be called behind C, rather it will be called in front of C, isn't it? But since this is the wrong direction, we are looking like this, so this is why this position will be called as behind C. Okay, so now we will draw 2 rays. Okay, we will only draw 2 rays. So now for the first ray, I will be using rule number 1. Rule number 1 means this one. Okay, in rule number 1, the ray travels parallel. Okay, the ray travels parallel. The ray which travels parallel, after reflection it passes through focus, isn't it? So it will pass through focus. Okay, it will pass through focus. This is rule number 1. Ray number 1, traveling parallel, after reflection passing through focus. Okay, this is ray number 1. Okay, I'll not write 1 and 2, it may confuse you. So remember, this is ray number 1. Now time to draw ray number 2. So which rule will I follow? See class, you cannot use the same rule, okay, in both the rays. No, that is wrong. You have to use another rule. So there are 4 rules available. Now remaining 3, you choose any one. Me, I will choose the second rule. In the second rule, the ray enters through focus. So let me choose that. So the ray enters through focus. So I will make the ray enter through focus. Okay. So the ray enters through focus. And then what happened? This is the incident ray. Okay, entering through focus. Now reflection will take place. So reflection has taken place, and then it will go parallel. It will go parallel. Okay. So it is going parallel to the principal axis. Now the 2 reflected rays, do they meet here or not? Yes. So here will be the image. Okay, so now you will get an inverted image. Okay, you are getting an inverted image. So that is the image. So image position, where is the image? Image is between C and F, isn't it? Isn't it? If you are told to describe, tell me the image position, how will you describe? Then you will have to look at the ray diagram and okay, the image is here. So how do I describe the image position? The best way to tell the image position will be to say that it's between C and F. So I will look at C and F, and yes, I see that it's between C and F. So you just have to look at the ray diagram and tell me, okay, right, what you see is between C and F. So just write between C and F. That's it, between C and F. Okay, size. What about the size? Now you tell me how the size will be. Look at the object size. Here size means the height, okay? Remember, we're talking about the height here. So height, size. The height of the size is this big, and here the size has shrunk a little bit, isn't it? Okay, so the size is much smaller than the object. The object is much bigger here. So size we can write diminished, okay? In your textbook, it's written diminish, okay? Because it is small, nah? Diminished. Diminished means small only, okay? Diminished means small, okay? Small. Diminish is also another word for small only, okay? Then nature, it will be still real, okay, class? So nature is real. Follow? Now we go to the next, case 3, okay? I have little room, so let me use this space also. Case 3. Now case 3, write the same thing again. Object position, then image position, then size, then finally what we write? We write the nature. Okay, I hope you are all following, class. So now time to draw the next ray. Let me create some room because I don't want to stoop down very low. So okay, so this will be the third diagram, back side. Okay, then I will have to stoop down. So then this is the principal axis. Okay, here is the pole. Okay, then you know the drill. Let's mark the focus. So this will be my focus. This is focus, then this much. So that means my center of curvature will be here. This is my focus. Okay, now class, where will the object be? We have to fill up this object position. Where will the object be? Remember I told you that in rule 1 the object was nowhere to be seen. Okay, now the object is in front of you. Now it will try to get more in front and more in front. Okay, so now previously in case number 2 it was behind C. So now in case 3 he will have moved forward, isn't it? So where will he be found now? He will be found standing at C. So now the object will be at C. Okay, so the object is at C. So the object is here. Okay, the object is here. This is the object. So let's do the ray diagram now. For 1 I will use rule number 1. So it will go like this. This is going parallel to the principal axis, and you know what will happen? A ray which goes parallel to the principal axis, after reflection it will pass through focus, isn't it? So this is the reflected ray passing through focus. This is rule number 1. Now time to draw the second ray. So let's draw the second ray. The second ray I will use whatever I used earlier, which is I will make the ray pass through focus. So make the ray pass through focus. Okay, then after reflection it will. Now this is the mistake. Actually it is supposed to be here. Okay, that is why we have to practice. Okay, so I have to draw again. So let me draw again. I have to get the image at C. I always make mistake here, so we need a lot of practice. Okay, class. So let this be F. This is F, then this is C. Object will be here. Okay, now then yes, at least we can take this one. Okay, we can take this one. We can take this one. We can take this one. I don't want to erase this. Okay, so it will be somewhat like this. Okay, needs a little bit of practice. Okay, I've been doing this for years and years, but still I'm making mistake. So maybe you will also make mistake. Okay, so please practice. Okay, then you will know. Okay, you will know. And if you ask my opinion, I will prefer you to use freehand. Okay, freehand is better. Using scale and doing that is also better, but practice with freehand. Okay, that's also better. The diagrams, they don't look so bad also. Okay, with freehand also you will get to draw almost straight lines also. So I will encourage you to practice with freehand. Okay, but it's up to you. So ray travels parallel, passing through focus. Ray enters through focus. After reflection, going parallel. Okay, so where is the image? The image is also at C. Okay, the image is also at C. So object position, where is the object? At C, means center of curvature. Yes, image position also at C. So at C. Okay, size, what about size? Class, tell me, what about size? In case 2, the object was this big, the image was a little smaller. In this case, this is the size of the object, this is also the size of the image. What is the size? What do I write here? Big, small, same. What is the answer? Same, isn't it? So same. So same as object. Okay, same as object. All right. And nature, undoubtedly nature will be real. So real. All right. So now we are done with the first, second and third. Now we will do the fourth, fifth and sixth. Okay, so we'll do the fourth, fifth and sixth. Why did I erase this? I should not have erased this. I'll not erase this. So case 4, I should only erase these things. Okay, let me just erase these things, because these things will change, whereas the other things, so they can remain as they are. So let them remain as they are. Okay, case 2 will change, case 3 will change, the other thing will remain. Okay, so these diagrams have to go. All right, now let me rewrite this again. This was position. I wrote here object position. This is image position. IMAG, image position. Size is here. Okay, now case 4. Class, now we are at case 4. Okay, case 4, object position. Now at case 4, the object will have moved more closer. Okay, in case 3, the object was at C. Okay, now let us draw the ray diagram for case 4. So the ray diagram, let us draw the concave mirror here with the pole. This is the principal axis. After drawing the principal axis, you know what to do, isn't it? So draw the focus, exactly take the same thing and mark your curvature. Okay, then it will be correct. Now previously, class, the object was here at C. Now we are moving to case 4. The object will also move forward. Okay, you know what is the goal of the object? To get closer to the pole. That is his goal. Okay, that is his goal. So let us see whether he will achieve his goal or not. Will he ever get closer with the pole? Let us find out at the end of the video. So object is here, was here in case 3. Now the object will have moved forward. Okay, so now the object will be here between C and F. Okay, so object between C and F. So let us draw the object here. This is the object between C and F. Let us draw the ray diagram. I will follow the rule 1 first. Okay, here rule 1 is followed a lot. Okay, rule 1, I think in all the 6 cases we follow rule 1. So rule 1 is very, very important, which is ray traveling parallel. After reflection passes through focus. Okay, so after reflection passes through focus, this is the one, ray traveling parallel. After reflection passes through focus, rule number 1 is done. Now time to draw the second ray, for which I will be following the second rule, rule number 2, which is ray enters through focus. After reflection, it passes parallel. Again here. Okay, though I'll use it. Okay, I'll use it. Should have been a little bit this side, but what to do now? I think I can do that. That is, I think if I erase this one. If I make this line a little, if I align this a little bit, I think I'll get a perfect figure. So let me do some adjustment here. Okay. Oh no, not like this. Like this, nah. It has to be straight though, after all. So, and again, this one. Okay, it's almost like that. What to do? Okay, but this is much better than the previous one. So here, the two reflected rays, they meet here. They are meeting here. So they meet here. So the image will be formed here. So not bad. Okay, so this is the image. Okay, image. So this is our C. Okay, object is between C and F. Object position between C and F. Okay, between C and F. Okay, object position between C and F. Okay, where's the image? Image is behind C, isn't it? It's behind C. Okay, it's behind C. Okay, we start our journey from here. So that means you will first meet C. Then after crossing C, you will meet the image. That means it's behind C, isn't it? It's behind C. Okay, so behind C. Okay, so this is behind C. Some of you may think, then doesn't that make in front of C? No, it's behind C. Okay, so image position behind C, because we move like this only, isn't it? So it's behind C. So behind C. Okay, behind C. Size, well, now size, look at the object, this much. This is the size of the object, and look at the image, much bigger than the object, isn't it? So size, this will be enlarged. We can say it's enlarged. Size enlarged, because it's bigger than the object. Okay, and nature, again, it will be real. Okay, real. Now case 5, we go to the case 5. Case 5. Now let's draw case 5. So let's do the ray diagram here. So case 5. Now the principal axis is here. Now let's mark the focus, and taking the same thing, my C is here. Okay, now this is case 5. Where will the object be? Now see, in the previous case the object was here. Now where do you think he will stand? He will stand at focus. Okay, he will stand at focus. So now the object stands at focus. So the object stands at focus. So the object is here, standing at focus. Okay, the object is standing at focus. Let me take a little bit big mirror, this one. Let me just take a little bigger. Okay, we have to do some adjustment. Necessary adjustment is needed. Okay, class, we have to do the adjustment, so you need to practice a lot. So now let us draw the rays. So rule 1, of course. Okay, rule 1, ray goes parallel. What will happen? After reflection, it will pass through focus. Okay, it's passing through focus. Next, now next ray, which one should I draw? So the next ray that I will draw, I will use the rule number 4 here. Rule number 4 is the one where it passes through pole, isn't it? So it passes through pole. So the pole is here. So rule number 4 I'm using, it passes through focus, pole, sorry. So it will make the same angle and pass away. Okay, it will go like this. So this angle will be the same. So this is me following rule number 4. Okay, rule number 4. I'm using rule number 4. Here I have used rule number 1 and rule number 4. Rule number 4 is here. In rule number 4, the ray passes through pole. Okay, so this ray that you see here, na, it passes through pole. Okay, and here the angle will be the same, but we are not going to show the angle here. Okay, here we are only interested in the ray. So now you look at the two reflected rays. The two reflected rays, they are traveling like this, parallel to each other. Will they ever meet? No, parallel lines, they never meet, okay class, so they are never gonna meet. So where will the image be formed? Well, wherever they, well, I don't know, but according to your textbook, it's at infinity, so we'll write at infinity. So image is formed at infinity. So object position, where's the object? At focus. Object is at focus. Where's the image position? Image will be formed at infinity. Okay, so at infinity, image will be formed at infinity. Then size, this is size will be highly enlarged. Okay, highly enlarged. Images formed at infinity are considered to be ginormous, means very big. Okay, so size is highly enlarged. Highly enlarged. The stars are much far away from us. We consider the stars to be at infinity, and you know that the stars are much bigger than Earth, isn't it? So it's similar to that situation. Okay, images formed at infinity are very big. Okay, then nature, again real. Okay, nature is real. Then the last case, case number 6, and the class is always very important class, very important case. Okay, this is the last case and also the most important case. Okay, every case is important, but this is also very important. Okay, now let's draw the ray diagram now. So let me erase this one. I need some space here. So case 6, I'll have to stoop down now. So let's draw the ray diagram. So go like this to the mirror, then draw the principal axis. This is the pole. Now this is the focus. Let's keep the focus here. Let's make it a little bigger. Focus here. Then same I go, and then I get myself my center of curvature. Okay, where will, maybe it's a little extra. Okay, now where will the object be? The object will be between F and P. Now previously it was at F, now it will be between F and P. So the object will be here between F and P. So let's make the object here between F and P. Okay, then rule number 1, it will go parallel. Area which goes parallel, after reflection it will pass through focus, so it will pass through focus. Remember class, it will pass through focus, so let the ray pass through focus. Okay, let it pass through focus. Now next one, the next ray, which rule should I use? I have already used rule 1 here. Okay, ray traveling parallel, after reflection it has passed through focus. Now I can go for rule 4, where I will use the same which I use here, or I can go for center of curvature also. Okay, which one should I use? I think I'll go and use the third rule, which says that ray which enters, which passes through curvature, okay, backtraces through curvature again. So maybe I'll use that. So for that, or I can also use the, I can use the fourth one. If I use the fourth one, it will look like this. Okay, let me use the fourth one. Okay, so let me use the fourth one. So the fourth one is one, making sure that the angle is same. Okay, let us continue. So like this. Is the angle same? Okay, this one back tracing will be a little difficult. Okay, we can go to the, okay, let us not do this one. Let us not take this one. Let me take the curvature one. Okay, because if I take this one, I have less space here. So let me take the other one. Let me take the curvature one. So in that case, this curvature here, okay class, this one, this curvature and this area should touch these two. So the ray should aim this, that. So make sure that here you may need a scale. Okay, so somewhat like this. Okay, it will go somewhat like this. So from the remember here the object is here, so the light is produced from here. So it first goes here, okay, arrow is here. Then again this ray, okay, will pass through this one curvature, so the figure looks a little what like this, okay, a little like this, okay. Then if I do this, then here look at the two reflected rays. The two reflected rays are here. See, they are getting, see the distance between the reflected rays. Here it was very less, it's not here, the distance between the reflected rays was very less, but now as they continue the journey, they're getting bigger and bigger. The distance is increasing, so it has increased a lot. Now here it will increase more, like that. So they are drifting further away from each other. So what we do is we have to, well, they are never going to meet here, for sure. So what we do is we will assume, so we have to backtrace this. And if we backtrace, we can confirm that they are meeting behind the mirror, isn't it? So we can confirm that they are meeting behind the mirror. Okay, so they are meeting behind the mirror, so the image is formed here. So we have to extend this one, and the image is formed here, okay, behind the mirror. Okay, the image is formed here behind the mirror. All right, the image is from here behind the mirror. So this one, this is rule number 5, okay, rule number 5. All right, rule number 5. Okay, let me draw this one again. I'll just show you one with the pole one. Let's try the pole one together. This is the principal axis, this is the pole, this is focus. If we try to get a good one, we get bad one. So now this time I'll just try to draw normal one. So parallel, passes through focus, then enters here, then yeah, this time I'll get, I know for sure. Okay, yes. So see, okay, when you don't expect, you get the best. So now you see, well, the same thing is happening here. So now they are not going to meet. So I'm using here rule number 1 and rule number 4, okay, whereas I used here rule number 1 and rule number 3. Okay, you choose whichever one is easy for you. Okay, so here same thing, backtracing has to be done. So if we backtrace this, then it will go on like this. If we backtrace, then it will go like this. So basically this is much better, I guess. So you go for it, you go for this one. That's why I'm drawing both. Yes, much better now. So of the two diagram, this is much better. Okay, so like I said, this is between rule number 1 and rule number 3, okay, where you'll get something like this. If you find that this is a little complicated, go for this one. Here you're using rule number 1 and rule number 4, okay. Ray enters through pole, okay, then making the same angle, it will pass through. So you get a bigger picture. Actually this is much better. If I were you, I'll go for this one. Okay, I'll go for this one. So opt for this one. Okay, then in that case, so okay, now object position, where's the object? Where was the object? Object was at focus. No, not at the focus. Object was between F and P. Sorry, object was between F and P. So object position between F and pole. Okay, P stands for pole. Image position behind the mirror. Class, behind the mirror. It's behind the mirror. So behind the mirror. Okay, no space. So please don't mind, behind the mirror. Size highly enlarged. Okay, highly enlarged. Look at the size. Object is this much, image is roughly 3 times this long. Highly enlarged, highly enlarged, highly enlarged. Okay, previously you got here, even here also we got highly enlarged. Now enlarged, highly enlarged, highly enlarged is also okay. Then or we can write enlarged also. Okay, so highly enlarged or enlarged, anyone you choose. Since we're using highly enlarged for infinity, I think we should go for enlarged or highly enlarged. You can check the textbook, okay, I'm not sure. Or it will be either highly enlarged or enlarged. You can check the textbook. And nature Nature will not be real anymore, class. Nature will be virtual. This is virtual because see here, okay, the rays are not meeting here. The two reflected rays, they are not meeting anywhere here. So we have to project them backwards and we assume that they meet here. So this is a case of a virtual image. So nature, virtual. Okay, and virtual images are always erect, whereas real images are inverted, isn't it? See, look at the image. The image is inverted. The image in all the 5 cases, case 1 to case 5, they're all inverted, okay? Because they are all real cases only. They are all real images. Since they are all real images, they are always inverted. This is a virtual image. That's why it is erect. So virtual, and a virtual image is always erect. So nature, virtual, okay, virtual, and image is erect. Image is erect in this case, okay. In this case, the only case in concave mirror where you get a virtual image is this, okay. I hope it's clear. So I hope you have understood something. So watch the video again and again, okay. That is the advantage of having a watching from YouTube. So you can rewatch again and again, okay. So we'll end the video from here today, and then I'll see you again in the next video. Study hard, okay, pray to God, and then all the best.